I'm Sandy Knapp. I'm a botanist from the Natural History Museum here in London, and I'm the current president of the Linnean Society of London. The Linnean Society is the oldest society dedicated to natural history. It was founded in 1788 by Sir James Edward Smith, and we hold in trust for science and for culture many of Linnaeus's collections and his library. We also have a large library and other collections as well. We are open, our fellowship is drawn from all ages and all walks of life. The Linnean Society Fellowship is open to anyone who's passionate about natural history. You don't have to be an academic. You don't have to be someone with a PhD. What's wonderful, one of the things that I find wonderful about the Linnean Society is that this is a place where people from all backgrounds can meet and talk about our mutual passion, which is the natural world, how to understand it, how to value it, and how ultimately that we can conserve it. So if you aren't a fellow of the Linnean Society, do please consider becoming a fellow. We have amongst our fellowship some really interesting people, one of whom will be our speaker this afternoon. Mark Benecke is a longtime fellow of the Linnean Society, and he's the godfather of some book restorations in our library. And I'm now sitting in our council room surrounded by lots and lots of books which are drying out from a small flood which we had the other day. Don't worry, nothing is terminally damaged, and our collection staff have been drying things out and making things good as soon as they knew. Fortunately, this didn't happen on the weekend. Mark works internationally as a forensic expert, mostly in the fields of blood spatter, forensic entomology, and genetic fingerprinting. Now, many of you have seen these television series called CSI, and I think that actually Mark is true life CSI. And so he'll tell us today about insects and corpses. And in his home Germany, he's a certified and sworn-in expert for biological stains in court cases. So this is true life CSI with insects, which is absolutely fantastic. Thank you so much for coming along this lunchtime, Mark, and over to you.
Yeah, it's a total pleasure. Thank you very, very much. I didn't know which tie to choose. The Linnean Society got society ties. I also could have used my Hufflepuff tie, which would also have been appropriate, or a fan tie with some bugs drawn on it, but I decided for the society tie. So today I'm going to talk very briefly, just half an hour, about insects and corpses. And since the title mentions the corpses, there will be a few corpses. So please switch off your laptop, computer, phone, whatever you have, tablet, if you don't like that. Also, please switch off if you don't like funny German accents, because I have a super thick German accent. But we have Germany and England have very, very strong ties relating sometimes to political things. And in my hands, you see, I have the wedding cup of two very famous people who also have relationship, or one of them has relationship to Germany. I also like a British breakfast. Germans think that Guinness comes from England, but okay, no matter what. And I do it vegan, and my wife, because one of the lessons that you learned from the past lectures here at the Linnean Society lecture series was that not using animals as food, no eggs, no dairy, no milk, no pork, etc., will immediately free 70% of the land and the water and reduce CO2 emissions also about 70%. So you can have a vegan, hearty breakfast in British style in Germany or wherever you want. It can be done on plant-based, and it will free a lot of water, a lot of space, and it will reduce CO2. At the Linnean Society, as you heard, I like old books, and I help to keep them in shape. I also do that in other very old libraries, but only for natural science books or for vampire books relating with vampires from the 18th century. Of course, you do have your own experts in Britain. For example, at the Museum of Natural History, the past chief of the department for Diptera flies was also a person, and he's also a fellow of the Linnean Society who knows a lot about forensic entomology. And as you heard from the president, I also deal with blood spatter. Here you can see me at a real crime scene dealing with a blood spatter case. And on the wall, you see a tiny sticker That is very important because it reminds us to measure everything and to never assume, never guess. You know who never guesses? That is Sherlock Holmes. So when I go to England, I once in a while visit Baker Street. Everybody knows that Sherlock Holmes lived there and had his office there. And he not only shot the name of the Queen into his wall, as you can see here, and there are also still some things that Sherlock Holmes recovered. But what most people forget is that he was, and you can see that in the back of the picture, he was a chemist. Sherlock Holmes was not a detective. He did not have an education as a policeman, and neither did I. I work a lot with the police and I learn a lot from them, but like Sherlock Holmes, I'm a natural scientist. Here you see the corner, Sherlock Holmes, again, he was a chemist, and I'm a biologist, so we look at crime from the biological side. If you ever go to Baker Street, probably being British, you won't do that very often, but it's worth it because you can see many interesting cases. For example, here, that's the severed thumb of one of the cases, but you can also see butterflies. And butterflies are insects. And why are they at the home of a forensic chemist, Sherlock Holmes? Well, that's because people knew a lot about insects living on corpses for a very long time. It was a famous topic since the 13th century, obviously starting in China, where a lot of things started. This here comes from France in a German edition. This is also from a German school book. And pupils from a former time, let's say in the 1960s, they had pictures like this just quite normally in their school books, because people saw death everywhere and the recycling of material, of calories, of fat, of water, of protein that is inside of a human and also of an animal and also of a plant body. And they just saw the circle of life and it was normal. So you could put that in a school book without any warning. Now what we do is we look at the flies and insects and bugs and beetles, and we distinguish them. And depending on which animal it is, it has a certain life cycle. So it ages. That means the adult flies will deposit patches of eggs or a blow of eggs. That's why they're called blowflies. A patch of eggs, for example, on top of the animal or under the animal or inside of a body cavity or close to the energy resource, and then we find out which animals these are. So what you can usually find, if you look in the internet, you will find blowflies, mostly blue shiny ones, the blue bottle, green shiny ones, the green bottle, but there are also many others. And what I want to show you is that it's the most important thing is to keep your eye open for things that you did not learn, things that are not in the book, like Sherlock Holmes does. So in the bottom, you see the cheese skipper fly. This is not in the book. So when we found a corpse, this was a person who killed himself on the rail tracks. This is still a very frequently performed act of suicide. You don't read and hear a lot about it because we fear that this will inspire other people to also kill themselves on the rail tracks. So this body was fully intact, completely intact, nothing broken, only the head was severed. The head was cut off by the wheels of the train. I know that because this is a case that I personally had. So except of the missing head, everybody was in shape. This was not a high-speed train. If you get in front of a high-speed train, then the whole body is shattered to pieces. Now, inside of the long bones of one of the large bones, when we opened it, so we cut it open. I was there when it happened. The cheese skipper larvae jumped out of the bone, which had no opening. So I was like, what the hell is going on? So cheese skippers are flies that prefer to go onto cheese. So the eggs are deposited on cheese, and then later they skip out of this sticky substance to pupate and become adult flies. So I looked up what time is necessary. So what is the developmental time for flies on bodies? But the problem is, if you watch CSI, this time interval that you determine out of the developmental time of the larvae will be the time since death. And that is not the case, because the cheese skippers like cheese, and human beings, human corpses are not like cheese. So you have to take into account the time since death in a matter that you calculate into it, the humidity, the temperature, but also this, for example, if this is on a slope, if the slope is shadowy or non-shadowy. And also the cheese skippers will start to inhabit, to develop on the corpse, let's say, for example, 2 months after the death. So this is not the time since death, it's the time of development after cheese skippers started to develop on the corpse. Now, how they got into the unbroken bone, I'm not going to tell you. I know you will hate me now, but this is exactly what happens on a crime scene. Nobody's helping you. You cannot ask anybody and like, well, could you please give me the solution and deliver it to me? No. So tonight, if you want to, and you have a sleepless night, then you can think about that and send me an email, and then I will tell you if you were right or wrong. But the point is, not all insects live on the corpse straight away after the death, even if they can reach the body. This is only true for the blowflies, or mostly true for the blowflies, and sometimes for flash flies, but sometimes not. Another thing that you can do with the flies is you can work with them in their absence. So you can work with them even if they are not there. This here is a case actually around the corner from where I'm sitting now in my library. And the police were like, come on, Mark, you live around the corner. You do a lot of unpaid stuff, you know, for when it comes to nature restoration and saving the planet and stuff like that, and cooking vegan British breakfast. So could you do that for free? That happens in 90% of the cases. So I was like, yes, okay. So I went around the corner and you see the outlines of a person laying on the body, probably, if you have a little bit of fantasy. On the bottom of the picture, you see the buttocks and the back. On the right of the picture, you see the knees, and you know they are a little bit like kind of bent and tilted. And on the left, there would have been the head. Now the outside consists of dried decompositional fluid. And the question that we were asking is, okay, where are our post-mortem interval indicators? Where are our maggots that developed on the corpse that is not there anymore? Now, if you look, that's also not in the book, in no book. Now, we thought, well, just take a closer look. And when you take a closer look, you can see the little lines that the maggots just produce, because when they walk away from the body, because they have eaten enough, after they reach third star larval stage for blowflies, they build a track for a while that is just decompositional fluid, because you know they're just crawling over the floor, and the decompositional fluid for a while is crawling with them, if you want to put it like that. So we looked under the blanket that you see there, and under the blanket we found our little post-mortem watches or clocks or indicators. Now, once I tell you this, you would say, I would have looked under the blanket straight away. Yeah, maybe you think that you would have done that, but you would not have done it, because I know from 30 years of experience with this that nobody is going to look under the blanket, but most people, like in CSI, would go to where the corpse is. So let's say the corpse is now in a trash can, or in the Institute of Legal Medicine, or buried somewhere. Then everybody is going to focus on the corpse. But that's probably not the best way to do forensic entomology. The best way is probably to look where the insects went. So I have to think like a maggot, and not like an offender or like, you know, any other type of scientist. Here's another case. This is a corpse that is very interesting. It's greenish discolored, it has a greenish discoloration by Pseudomonas. That is a bacteria of which I could give you another lecture, but I won't. And when you look a little bit closer, you see my little crime scene sticker, the scale that I talked about earlier on the side of the body, like in the middle to the right bottom of this picture, you see a little reddish dot. And since I'm the biologist, I play stupid, and I just told everybody, the police and the forensic guys who are doing like forensic medicine, or in the United Kingdom, probably coroner or forensic pathologist. It's different in every country. And I told them, can I have that stain? And everybody was like, you know, this is really not related to anything. And I'm like, interesting, not related. I mean, to me, it's interesting because, I mean, there's something reddish that could be biological sticking to the body. So I got my stain. I bred my stain, and it was a fly pupa that was reddish brown, which is often the case when you deal with calliphorids, the blowflies. But what is very unusual, again, you know what I'm saying now, it's not in the book what happened now. I bred my pupa, and after a while, a fly came out. The fly, I let the fly go because you can determine the species and therefore the developmental parameters out of the pupa. And I like flies, so I don't necessarily kill them, even if they come from a crime scene. But sometimes you have to, but I try not to. And then you see the little red dots, and the red spots and dots, they were unusual because the flies, when they become flies, they undergo histolysis. That means the whole tissue becomes something else. It's, of course, the DNA is the same, but you have a worm-like maggot that pupates, and then the whole tissue kind of becomes a jelly again, and out of that, you get an animal that has eyes and bristles. Oh, by the way, if you're interested in that, there's a new book out from England, of course, from the Royal Entomological Society, brand new. It arrived yesterday with all those details, eyes, bristles, and everything else. We use that in the laboratory. And this is a big wonder. This is a real miracle. I mean, imagine you're a kid and you ask yourself, how could genetically a totally different animal be formed inside of a pupal shell? A German female scientist, biologist, got a Nobel Prize for answering that question, Christiane Nüsslein-Vollhardt. So if you ask childlike questions and feel the miracle and the wonders of nature inside of you, sometimes you can even get a Nobel Prize or become a forensic biologist or become something that is really interesting. Now, I took the reddish dots and I pestered one of my colleagues. She got a degree in biology and medicine. And I asked her, could you have a look at, what is that? And she's like, okay, Mark, deal. You don't contact me, no matter how urgent it is, because I don't want to hear anything about death and police work and forensic stuff. I really don't want to hear about that. That happens in now 99.9% of cases, but I'm still friendly to my colleagues, and I buy them dinner and so on. So sometimes they do something for me. In this case, it was Serratia marquescens. This is a bacterium that is everywhere, probably in all of your oral cavities, your mouth right now. Whilst I'm speaking, it's everywhere, but it doesn't develop. You don't have reddish dots everywhere. So I'm like, how did the reddish bacterium, it is red out of itself, you don't have to stain it, come inside of the maggot? Then maybe the maggot pupated, and then later on, when the adult fly hatched, this came out of the maggot. That was strange for me. So I went to the library. I like real books. And inside of those books, this was at the beginning of when AIDS became a huge problem. So, I'm old. And there was a little brand new article, and it said, well, Serratia marquescens, the red dot or red blood drop bacterium, sometimes develops when you have immune deficiency. So I went to the medical doctor when the person was still alive. So the real medical doctor, the day-to-day medical doctor, the practical guy. And I asked the person, say, did your patient, before the patient died, have an immune deficiency? And the medical doctor said, yeah, he was an alcoholic and he had a super immune deficiency. So I went to the police and I told them, case solved. I think this person died from an immune deficiency, and my stain, my trace, my evidence is the blood drop bacterium. And then the police told me, oh, Mark, very well done. That's a nice case. Go away, because we don't, investigate against bacteria. So this can also happen. You do get a clue that in reality probably even solves the case, but then the police is not interested, because then it's not a case anymore. If you die from alcoholism or drug abuse, then the criminal police, at least not the homicide detectives, are interested. However, that is good, because that gives you a chance to do free work for the police in many cases. So here you can see one that once again, they just called me in, and it was a person who died again in their apartment. And what I do in those cases is I look at the pattern of colonization. You know what's coming now. That's not in any book, the pattern of colonization. So for example, here you see that the pattern is that the flies, in this case, these are blowfly larvae, are distributed at the ears, the eyes, the mouth, but not anywhere else. The rest of the body is dried out. And that means that in this case, nothing happened in the sense of a violent offense against other parts of the body. You don't see the rest of the body, but I'm telling you, there are no blowflies, or as we call them, maggot carpets. It's a beautiful word. Also, when you lay awake tonight, think of maggot carpets. So there are no patches of maggots, of larvae, of blowflies anywhere. That means that there were no, for example, knife wounds, stab wounds anywhere else. Because if you have a stab wound, let's say in the area of your stomach, your belly, your abdomen, or at your back, or even at your arm, then adult, pregnant, gravid female blowflies would deposit eggs there because they like wounds, but they don't like regular skin, except mouth, nose, and ears, because this is an area that will decompose very quickly, and that's also very soft and nice for the blowflies. Usually the maggots are used, and that's what you probably see in CSI, are used to calculate the developmental interval. I told you that already. And this is done until today. This is from some Polish colleagues. And you can see this is still a topic. Again, since the 13th century, I already mentioned that. And it's still a topic. So you can see manuscripts that are still accepted today dealing with the topic. And usually what we do is we look at growth curves. So at the left, you see the length of the maggot, and on the bottom and on the top, you see the time since hatching. I don't want to go into that too much, because on the one hand, it's very technical, and on the other hand, that's something that you probably heard or read or saw in crime movies or books. I would like to use the remaining time to just remind you, don't do things that are in the book, because this is in the book a lot, and you can learn that very easily. But what you should probably much more focus on, especially if you're a little bit younger, is to go to the actual scene and work on the case as a biologist. That means forget if this is sad or not, forget if this is disgusting or not, forget everything, because that's not why we are there. This is a case for the priests and for the police and for journalists, but we are biologists. So I'm asking myself, in this case here, where would I find the oldest blowfly larvae or pupae? If they, most of the times, most fly species don't pupate on the corpse, but some do. So in this case, the answer is, okay, the head is under the water. So head is not so relevant for me, but probably the area of the decomposing genital area, because that's beautiful for my maggots, because they like it wet, they like it warm. The underpants is like a tent, so it's going to heat up due to the sunshine. This was a very, very cold day and very cold season. You don't see it in the picture because I'm wearing my field clothing there, but it's very cold. So the maggots would probably hide under the underpants. And again, if I'm asking the police, could I just take some maggots out of the underpants, because they are probably my oldest watches or clocks, my oldest indicators for the developmental interval time of the insects, then everybody's, it's like, yeah, take it, but then please go away. Because after that, we do the real stuff, the police and forensic pathology stuff. And I'm like, again, very good. So I have my stains, and in some cases they become relevant. In some cases they are not relevant. But the problem is, if you go to the Institute for Legal Medicine or forensic pathology or to the coroner's office, those stains will be washed down the drain, because the medical doctors are going to shower the body to have a clear and nice body. And nobody's going to take out the maggots out of the drain pipe for you. And I'm also not very keen doing that, because you find a lot of things there that are not related to the case. insects, as you can see here, this is done by my students in Medellin in Colombia at the university. They did a little wall painting here. I work in many countries, also in Colombia. And you can see that the 6-legged and also the 8-legged animals, let's call them spiders and insects for now, are the largest group of animals on planet Earth. So if you are the person who is working with information from the book, but also all the information outside of the book, then you will find a lot of animals that are not even related to corpses at all. But they are just there by chance. We did a very large study. It was a lot of work. It was horrible. The student who did it afterwards decided to become a teacher in a school and to never do scientific work again, because we told him, okay, for half a year, you're going to live at the edge of a forest, and then you're going to look which insects are just around our dead animals that we are putting there. This is published, and if you're interested, you will very easily find the paper by just Googling what is the edge of a forest, and then you will find that. Now, my time is nearly up, so I cannot show you more cases, but I just want to show you something about determination that is very often forgotten by now. Oh, that's one of my crime scene stickers. If you want some of them, just go to a lecture of the students or of me, and then you're going to get one. One thing that you probably heard is that last week it came out that many of the insects that are in barcoding databases carry the wrong name, because the DNA was put in properly, but the morphological determination was wrong. And what I teach my students, even though they don't like that, but I don't care, I'm the boss, cut out the mouth parts of a maggot. These are the 2 tiny hooks that you see in the front. You just cut them out and look at them and make a drawing or a good photo, because they carry so many morphological features that this is probably a much safer determination than using a warped and not so good DNA barcoding database. It's a lot of fun because we call this, you can butterfly the mouth parts, so then they are open. And then you look for little features. For example, I won't even say the Latin name. I just put a little arrow head there. And this is something that helps you to distinguish which species of fly larvae this was, even without breeding or growing the fly, because it's much easier to do that with an adult fly. But I'm one of the few laboratories who does it morphologically with the actual maggots. There are very few people who do it, and I know I sound like a very old white man now, which I am, but it's really good to look at the actual biology, the real humidity, the real scene of the crime in the biological sense, shade and light, and everything that your kind of caricature, like comic style fly catching old biologist would have done. Now I show you a little trick when it comes to the end. Even if you just have the pupa, you don't have the larva, you don't have the adult fly, you still find the mouth parts, the mouth hooks, because they are still there in one part of the pupa. Isn't that Sherlock Holmes style? I think it is. And one of my students also decided that it's a nice tattoo, and she got a blowfly tattoo, mouth hook blowfly tattoo. If you are more into genitals, you can also learn how to distinguish adult flies from their genitalia. You look at some parts of their genitalia, you have to pull them out. It's also a nice job to pull out genitalia. Some of these flies are really small, like a seed, like a plant seed. Pulling out the genitals is really something. And you can see on the right side of the picture, sometimes, for example, you have a straight shape of one certain part of this genital area, and sometimes it's bent. So if you want to learn that, you can go to Museum of Natural History in London, you can go to our laboratory, you can go to Linnean Society and find somebody. You can buy the book from the Royal Entomological Society, who is a partner of this speech, by the way. And then you will see it's a lot of fun, because then, for example, you're going to be invited to look at the mummies of Palermo. If you look at those skeletons or mummies, if you look inside of the mouth parts, you see crime sticker, of course, there. and then you will find biological traces, and those biological traces will even tell you after hundreds of years what happened. In many cases, I'm called in as an expert for cases that are 1,600 years old. And even then, in many cases, you find the insect evidence because nobody took care of that. Everybody found it disgusting, boring, and of no relevance. And that's a lot of fun, I can tell you, because my assistant, who's on the other side of the screen, Tina, and I, we were invited to spend a week only at nighttime in the largest mummy basement of the whole planet Earth. And I mean, that's a dream come true for the little boy and the little girl that we are still as adults. If you want to look into that paper and find out what we find out, just Google mummies of Palermo insects Benecke, and you know already what's going to happen, or what I'm telling you now for the last time. We found a lot of insects that are not in the book and that still tell us a lot of how the mummies were produced. What did they do to get such a large mummy collection? How did they store the mummies? How did they dry the mummies? And the quick answer is they had no idea what they were doing. It just happened randomly. And we can prove that 100% sure and talk at an archaeological congress, and then people will be very surprised. You can be glad that the time is up, because I would have some much more gruesome cases, but I won't show them. I will just show you one of my favorite quotes from Sherlock Holmes. I never guess, because it's a shocking habit destructive to the logical faculty. And that is the case. Never assume, never guess. Look at the facts. And the president of the Linnean Society, I saw her a while ago during a talk that dealt with a topic that was not related to vaccinations, but people were talking about it. And she knew, like everybody else who's a natural scientist, what the data is, and the data says you need to get vaccinated. And she was like, just get your shot, discussion is over, because data in many cases do tell you something, but you need to get the data. And remember, the data are not always there where the book tells you. You can always go at the body farm. That's a facility at the Institute for Forensic Anthropology at the University of Tennessee. They have a lot of human corpses there. And if you're interested, again, just send me an email or Google some of our papers of the Polish colleagues, of the colleagues from United Kingdom. There are people everywhere who do it, and the papers are all online for free. Death is not the end. I hope you see that that is actually true. You will die, I will die, we all will die, but at the end we are just calories for the rest of the world, and all our proteins and all of the water and everybody else is just going to be recycled and going to be a part of the living, beautiful biological world. Thank you very much. And now I'm open for questions.
Thank you so much, Mark. And that's a very, very important thought to end on, and thinking about how important insects are during this, which is National Insect Week as well. Insects are important for being beautiful in our gardens, but they're also really important for their kind of absolutely pivotal role in recycling. We've got a few questions coming in the Q&A box. The first one is there any difference with sex, skin color, or age? And I think that what the questioner means is there any difference in kind of developmental times or anything? Does the type of body make a difference?
No, we are really all the same. In Germany, that was a big topic, of course, because of National Socialists, but in many other countries too. And we know now biologically, we know it for a long time actually, but I have the most clicked presentation that I ever did. I'm just rambling about that races on a biological level just don't exist. It's just, I'm just rambling on for 1 hour presenting the biological evidence. And this is the most clicked video I ever did. So it seems to be a topic, and flies and beetles and everybody else would never distinguish human beings when it comes to the recycling concerning skin color or anything else. There's really no difference. Races just don't exist. It's just a cultural construct, and skin color is of no relevance for anything biological.
So a body is a body, a body's a body is a body.
It's calories and fats.
Yeah, calories. Here we are.
Carbohydrates.
Exactly, calories and lovely moisture. Are there any official is there any kind of official training outside of your lab, for example, which is provided for maggot identification? Giuliano says that his group would benefit a lot from that.
Yes.
Do you know of anybody else who does any official training
yes.
courses on?
We all know each other. We are such a small field that this is one of the rare cases in which we actually do know each other. A very nice training is done by, I won't say the Polish name. His first name is Krzysztof. It would be probably Christopher in British, so Krzysztof. He was also a student of mine, and he has a beautiful training for identification of flash flies, blowflies, and everything in Toruń. It's a city in Poland. You can very easily reach it. It's a beautiful old city. So, and they have very good beer also, not the British beer that is sometimes a little bit questionable.
You're selling
it. Irish. That was Irish. And we do it, but also you could just go to the, for example, the now head of dipterology at the Institute, of the Museum for Natural History in London, of which Sandrak has a very good connection. Obviously can very easily provide you with the training. They could do it in-house. You can go to any museum of natural history, even in Berlin, for example. In the United States, you can even get kind of a certificate, a board certificate, to get a board certified forensic entomologist. In Southern Africa, they have also good connections to England, of course. You can do that with a colleague. So it's very easy. Just send one of the colleagues who is in the field an email, and we will provide you with the person. But if you're in England, just go to the Museum of Natural History and say hi to the head of dipterology there, and he's going to find a solution for you.
Great. Somebody's asked if there was any online training, and I don't know if there is as of yet, but I expect that will be happening soon, as travel is becoming a bit more difficult for everybody.
Linnean Society might provide that, because I'm even part of
Good
a podcast.
Suggestion.
Of a Linnean Society podcast and so on. So Linnean Society becomes very digital, but it's very difficult.
Yeah, there's a follow-up question from that. There's a.
Go ahead.
So go ahead. Sorry, I'm sorry. Doing it online would be difficult just because of its.
It would be difficult because the students don't know the Greek and Latin terms anymore. So what we need to do, and Royal Entomological Society did that with this brand new book that, like I said, just came out. They were putting in a lot of pictures. We did that also, but I think that is going to be the solution. But the problem is you need a person-to-person translation service, because sometimes there are still Greek and Latin words in there, and the students who come from molecular biology obviously don't use Greek and Latin. When I was in a laboratory in Manhattan, I was employed at the chief medical examiner's office in Manhattan. For example, I got a real stiff announcement that I'm not supposed to use Latin and Greek, and if I'm going to do that again, then something's going to happen from the city. So, you know, that would be something that is better done on a person-to-person basis, but it's no problem. I will help you. Museum of Natural History is going to help you. We will find somebody to provide you with any type of training. We're going to find a solution.
Okay, there's a kind of follow-up question to the first one from the same person who asked it. She says, but is the skin of children is softer, and doesn't that accelerate decomposition? So would age make a difference?
Yes, many features of a human body may accelerate or slow down decompositional processes, but the flies are not affected much. So for example, if you take cocaine, the maggots may grow faster in the beginning, but then slower in the end. But the question is, do the maggots reach a relevant amount of cocaine in your body? Let's say if you died from something and you also took a little bit of cocaine. Same is true for kids. So for example, probably I'm going to share the screen for the last time. Here, we had a case with a kid, and this is a case where we really know I'm not going to show you the dead kid. I just show you the live kid. On the top is the mother. The mother could not take care of the kid. On the bottom is the grave. In the middle is the kid. That was a long time ago, 21 years ago. But what we did was we took the maggots. This is from, we always re-examine our evidence a few years later to avoid mistakes, for example, by wrong identifications. So this is why you see the year 2008 here, even though this happened in the year 2000. So 8 years later, we re-examined everything. We had totally different maggots in the genital area compared to the facial area of the kid. And that we had animals in the genital area told us that the child was neglected for a certain time before it died. So what we did, we calculated the neglect time because that was relevant for the court in this particular case. Now, you are right that the decompositional processes may have gone quicker with the kid, but the developmental time of the insects is not affected by that because they use the early resources that the body is for them, as you already heard, proteins, carbohydrates, water, etc. So in the very beginning, it doesn't make a difference. But you are right, there are differences, of course. But with the early inhabitants, the blowflies, for them, it doesn't make a difference.
Great, thank you. Someone else has asked, it says, thank you. We've had lots of messages saying, thank you, amazing talk. So thank you. But he asks, have you ever found collections of insects on a corpse that suggest conflicting stories about what happened?
Not so much to us, because like you mentioned in the beginning, I'm officially sworn in and certified expert. That's a burden actually, because I'm the only one in Germany. And it means that I'm fully responsible for my statements privately. So for example, if I screw up a case big time, then I would lose everything that I have in the literal sense of the meaning, everything. Because then they could charge me for that. And this means that our expert witness statements are very sharp and always provide the literature. So everything we say, every single sentence is based on the most current state of science, state of the art, if you want to put it in a term like that. And that makes us very, this makes it very easy for us. It's a lot of work, of course, because we always have to read the latest articles. Okay, I'm a referee in many cases, so that's not so much of a problem. And in the case of conflicting stories, we just write it in. Another thing is we must think for the opposite side. So for example, the DA's office, the prosecution, or the defense, or a journalist, or you as the sister of the deceased person, you give us the case, we must write into our expert witness statement what the same evidence could mean for the other side. So conflicting evidence, no problem for us. We just write it in openly.
But so I think the question is more about how often is it that you find a corpse that has flies on it that tell you different stories? Do you see what I mean? It's more, I think the question is much more, you know, how often is it quite straightforward, and how often do you have two insects that tell you something different?
It's always tricky, because another Sherlock Holmes quote, it's only a trifle, you know, that's out of my brain now, it's not properly done. It's only a trifle, but the most important things are trifles. And that is the thing. A case can never be straightforward. If you do think that a case is straightforward, then quit our field immediately, because that is a misconception. But I can show you an example for that. Do I have the time to show another picture, or should we stop now? Okay, I'll just show it to you.
Just maybe one.
Okay.
Yeah, because that's the last live question. So
yeah, okay. That's a typical case. Allegedly, an offender put maggots from a fisherman's shop, which are also blowfly maggots and are from the same species that we find on corpses, because they are bred on corpses, these fisherman's maggots. What happens if they are put on the body, and then you have two conflicting evidence, because you have two different postmortem intervals, so to speak, or developmental times. And so we just took the maggots, and what we found out is that those maggots do not like the corpse, so they crawl away. So what you still would find the maggots and the pupae or the flies, but they would be at the wrong location inside of the house because they crawl away from that developmental or decompositional state of the body. That means if you go to the actual scene and if you really observe where the flies are, in the genital area, in the eyes, behind a cupboard, you know, no matter where they are, this tells you the biological story. And from that, I would say you don't get the kind of journalistically conflicting stories. And therefore, until now, we never run into problems.
Somebody's popped in the chat, there's always a simple answer and it's usually wrong.
Yeah, exactly. Well, the easiest answer is the correct answer, but it's a lot of work to get to the easy answer. So the easy answer comes sometimes after 15 years of research and experiments. You always need to do experiments, but the initial easy answer, that is true, that is certainly the wrong one.
We've got another question is, are there insects or arthropods that are only active on a body in water?
Yes. Caddisflies, for example, are not interested in the decomposing body at all, but they attach to the body. If you're interested in a case, just Google caddisflies, Mark Benecke, History of Forensic Entomology. There's a complete case dealing with caddisflies that by accidentally, randomly, attached to a submerged body, and that helped to determine the time since submergence, if that is a word, since the body was submerged in the water. It's a word. It's a word. Yeah, so they would be very interesting and very typical for us. However, no forensic entomologist has any knowledge about caddisflies, so you need to make a lot of phone calls through into all museums of natural history to find an expert for caddisflies.
Great. Oh, Mark, thank you so much. And I don't see any more questions. There was a lot of comments in the chat about how entertaining and useful that was, and how many kind of messages beyond just the amazingness of insects there were in that talk. So thank you very, very much, Mark, for giving us this talk during Insect Week. And I hope we can spend the rest of the week celebrating insect life. So thank you so much. And we hope to see you here in Burlington House soon.
That I'm going to come as soon as I can. And
Excellent.
Also, dear viewers, do become a member and then later on a fellow of the Linnean Society of London.
Thank you so much. That's a good way to end. Thanks a lot, Mark.
Yes,
thank you.
Bye-bye. Thank you very much.